All right, hey, look up, please. Press. Hey, reminder. Today we will finish discussing this packet. So we problems 3, 4, 5, and 6. You don't have school on Monday.
Yeah.
When you come to class on Wednesday, you walk in, I'll have dividers. Okay? I'll have one of these on your desk, or I'll hand it to you. So this is exactly what the AP test looks like.
Really?
Now they put it in booklet form instead of just flat pieces of paper. I can't really do that easily. So you'll see this. You just go to work. Okay. As we discussed, the class period is like I think 82 minutes, 83 minutes. The actual test time limit is 90, but we'll probably practice with this slightly shorter time limit so that when you take the actual test, it feels a bit longer. Technically, you would have half of the time to do problems 1, 2, and 3 with your calculator. Then you have to put your calculator away, and then you can work on any of them. Since you have kind of this pre-study available on this test, I'll just let you work the first 3. When you feel like you've done those, if you're done before halfway through, you can just go ahead and start on the rest. We won't worry about the strict timing on this one. On future ones, will probably be more strict. Questions about what happens on Wednesday? Okay, cool. Make sure, like before, you don't put your name, put your student number. Okay. So here we go. Problem number 3. So problem 3 says, move this out of the way for a minute. So problem 3 says, the rate of fuel consumption, I pay attention to the word rate. Gallons per minute. It's given by a twice differentiable. The word twice differentiable shows up in a lot of AP problems. Most of the time I don't need that clue. It's not used, so I don't typically circle that one. The fact that F is increasing, that is often, not F, but R I should say. So R is increasing, that's often needed. They give me a graph of R. The table always shows selected values, so we're good there. I probably circle the minutes just to keep track of units. Question? Cool. Use data from the table, so here, to find an approximation for R prime of 45. So this is R. 45 would be right here. R prime means the slope right there. So we're trying to approximate that tangent slope.
So that's awkward.
Okay. On your golden notes, so I'll keep referencing those so you can find the key pieces of information. Golden notes, front side, middle, says you approximate an instantaneous rate of change. That's what we're doing. R prime is an instantaneous rate of change. You approximate an instantaneous rate of change by calculating an average rate of change. So here's the formula. So I'm going to use this formula. Oh, yes.
I don't remember this.
It was on the last test. So test 4 had a question on this.
I guess I failed that.
So R prime of 45 is going to be, let's see, I look here and go, 45 would be in between these two.
Oh, yes. Now I remember.
There we go. So I've got to take R of 40, subtract R of 50. So I'm going to write that down. R of, let's go 50 last minus first. R of 40 divided by the time period, which would be 50 minus 40. So that matches up exactly with what you see on the golden nose. Please, Kimberly.
Do you have to write like R50 minus R40, or could you just write like 55 and 40?
You do not have to write this. You can just write 55, double for Cambridge, subtract 40, divided by 10. This will get you full credit. Right there. Don't stop here. If you stop here, you won't get full credit. Questions?
So the equal sign?
The equal sign is, so R prime of 45 is approximately this.
Yeah.
But this is exactly that. They're somewhat lenient on the approximate thing. If you forget that, it's okay. So. Anybody else? Cool. Show the computations. Did that. Indicate units of measure. The units of 55 are gallons per minute. The units of 10 are minutes. Key thing, read carefully, just like you saw me do. Just little by little, don't do it all at once, just slow and careful, just working your way through it. Questions? Cool. We check the scoring. One point was for this, and then 1 point for the units. You don't have to work it out, you can stop. Please.
It says here for like the answer, it's gallons over minutes squared.
So either way, this is correct, they'll give you full credit for it. What they did is they took that, so they took gallons per minute, and then they divided by minutes, right? But dividing by minutes is the same as multiplying by 1 over minutes. So that's how they got gallons per minute squared. But you don't have to, you can just leave it like that. So, Pebble for Boston. Question? Cool. Part B. Part B says the rate of fuel consumption. So here's my rate of fuel consumption is increasing fastest. I can, at time 45, that makes sense to me. This is a graph of R. I can see R going up the quickest right in here. So increasing fastest at that time. So time 45, that's T equal 45. So the rate of fuel consumption is increasing fastest at time equal 45. What is the value of R double prime of 45? And it says I'm supposed to explain my reasoning. So this is R. Let's see, maybe Danica's chart would help. So I go R, R prime, R double prime. Let's see. Okay, I'm going to illustrate something very important right now. So all eyes on me. And I am very serious about this. If you're working, makes me emotional. Water. Okay, if you're working a problem and you start to feel how I am now feeling, I've done this one before, I've done it multiple times over the years. It still is difficult for me to mentally process this question and come up with a valid reason. So here's my strategy for getting a 5 on the AP test. When that happens to me, this is what I do.
Okay.
Do you understand? I just go to the next problem. Like, it's not worth staying. There are 54 points available on the FRQ. I can miss 18 of them and still get a 5. So I don't want to spend any time sitting there wrestling with, wait a minute, is it this, is it that? I can't quite figure out how to do it. Keep moving. Like, do stuff you can do first. because hard problems count no more than easy ones. That problem there was worth 2 points. An easy problem is going to be worth 2 points. So don't spend time struggling with a hard 2 points when you can get an easy 2 points. So we're just going to skip it. If you want to study it on your own, you're welcome to. I'm not going to take time in class because it's not worth it. So.
Good to know.
Questions? Part C. Part C says, let's move this out of the way for a minute. Move this off. So part C says, approximate the value of this integral using a left Riemann sum. Okay, I'm back in comfortable territory. I know how to do Riemann sums. 5 subintervals will be important. Left is important. Indicated by the table, there's a period there, so I stop right there. And I go to work on this one. So let's see. I would say, I always write the integral first. 0 to 90, r of t, dt is approximately. I look at my table, I need to break it up into 5 subintervals. I need the value of r in the first subinterval. I need to multiply by dt for that subinterval, like that. Questions? Just repeat the process. You'll end up with this. We'll cheat and use their little thing. So there's their work. So we'll do the explanation in a second. Questions? Please, Mike.
Do you have to add it all up, or can you just leave it as the equation?
Just leave it as the equation. So this part here is not required. Double for Maya. Is this numerical approximation less than the value of this? Explain your reasoning. Okay? I do a picture because I struggle to remember otherwise. So I think, okay, I'm doing a left Riemann sum. So here's the first subinterval. It goes 0 to 30. And so there's my 30. The 20 is this value here. So when I multiply those two together, I'm finding the area of this rectangle. If I were doing the exact integral, I'd be finding the area here in green. So my Riemann sum is an underestimate. Question? I look at the back of the golden notes to remind me how I'm supposed to write my answer. And you'll see several examples on the back. It says right here. So in this case, I'm integrating r. So r is increasing. So the left Riemann sum is an under approximation. So I use that information. I put down on my paper basically this. Yes, the approximation is less because the graph is increasing. Questions? Please.
So because you have a calculator, can you find like 3,700 or like is that?
It's totally allowed. I just wouldn't. They're not going to give you any extra points for doing it, and it just takes time, and you might make a mistake. So, okay, couple. Next one. Okay, part D. Part D says, pull this out of the way, pull that out of the way for a minute. Okay. From 0 to 90 minutes, where B is in between there, so B is between 0 and 90. Explain the meaning of this integral in terms of the fuel consumption for the plane, and I stop at the period. So I just want to do that much. Basically, all you have to do is just think about what the integral is calculating. We are integrating the rate of fuel consumption, when you integrate a rate. There's some reminders here on the golden notes right here. In fact, this problem was used as an example. Rate of fuel consumption in gallons per minute is R. So this is actually the answer to this problem. When you integrate the rate of fuel consumption, you find out the amount of fuel consumed. When you integrate a rate, you find out the change in the amount. In this case, it's not really a change, it's just like how much fuel was consumed for that time period. There's a reminder on this side of the card as well. You integrate the rate of oil flowing through a pipe, you find the amount of oil that flows through the pipe. You integrate the rate of gravel arriving at some gravel pile, you find the amount of gravel that arrives during that time. So you just need to write that down. So I would write, I think I've got it right here. So I would say the integral from 0 to b of r of t. I have to make sure I use units. This calculates amount of fuel consumed. You can't forget units. In gallons for the time period. So for t equals 0 to t equal b, and you can't forget units, minutes. Anything about that you want to ask? Cool, keep rolling. Next one says, let's see the points on that. Their wording was slightly different, but pretty similar. They wrote, you have it on your paper, 0 to b, this integral is the total amount of fuel in gallons consumed for the first b minutes. So, the points that were awarded, they gave 1 point for having that meeting. If you leave off any of the units, you will lose the points, so don't forget the units. You're supposed to explain this as well. Well, with the 1 over b, you're finding the average of r. Since R is the rate of fuel consumption, you're calculating the average value of the rate of fuel consumption. R is measured in gallons per minute, so those units are required. It's happening for the first b minutes. That problem overall is worth 3 points. 1 point for the first meeting, 1 point for the second, and then 1 point for the units. Questions? Apparently very soothing voice today. Drifting off, so. Okay,
It's Friday.
there's that too. Number 4. And what intervals, if any, is f increasing justify your answer? Straight Danica's chart. F is increasing when f prime is positive. So I write down f is increasing for -3 to 2. The first three are calculated out. The last 3 are non. So this is no calculator because f prime is positive on that interval. That's all I need to write. I get 2 points for that. Please.
Isn't it -3 to -2?
How many saw the mistake? Show your hands. How about for that? And that would have cost me a point. Like, they won't be lenient on that. So, my soothing voice is causing me to go to sleep as well.
Does
Please.
it matter if you use brackets in this situation, or when do you know?
So,
Oh, okay.
in some situations, they'll accept either. And what I've noticed on more recent tests is I feel pretty safe just almost always using this. So you'll see me almost always do this. You'll see some of the scoring guides do this. But in the more recent FRQs, they've gone to this style.
Okay.
So
So
I'm
it's
just
correct
gonna,
that you're not
I'm just
missing.
going to use parentheses. Yeah. How about for mine? The wording here sometimes I struggle with. So on the golden notes, if you look on the back, it's all just lots and lots of phrases that you have to write. And so this to me is helpful. For example, the one we just did is write, where's the increasing one? Right here. Ours would have said f prime is positive for this interval, so f is increasing on that interval. Next thing. Part B. So part B says, find the x-coordinate of each point of inflection on the graph. Justify your answer. So I remember this from the golden notes right here. Front page. Where's the bottom? F has an inflection point when F changes concavity, or F prime changes increase to decrease, or vice versa, or when F double prime changes sign. So in this particular problem, I'm looking at F prime, trying to figure out when F changes concavity. Questions on this? So back here I write F prime changes, let's see, decrease to increase at x equals 0. F prime changes, increase to decrease, true, at x equal 2. So F has inflection points at x equals 0 and x equal 2. That would give me 2 more points. It's very exciting. Questions? Cool. Again, if you can't quite remember how to phrase it, if you just look on the back of the card, there's an example right here. Where'd it go? Here we go. At x equal 5, f prime changes increase to decrease, so f has an inflection point at x equal 5. Next one. Find an equation for the line tangent to the graph of f at point 0, 3. This is f prime. You need a line tangent equation to f. So f has some other appearance. Maybe this is f. Let's see, there's a line tangent. That didn't work out as well as I'd hoped.
Mine turned out great.
Good work. Okay, little curve to the top. Paid pebbles just to wake everybody up. Raise your hand if you know what equation goes here. Come on. Pebble for all. What equation goes here? Don't get pebble if you don't raise your hand. Elijah, what is it?
Y equals m put 0 x minus x1 plus y1.
Who had their hand raised and knew it? Mark down 2 pebbles. So let's see. The point of tangency on f is 0, 3. So I know that. All I need to know now is the slope of f at 0. I need to know the slope right here. So raise your hand, please, if you know the slope at that point. Look at the problem.
Where?
The slope right there on F. So what's the slope right there on F? Lindsay?
-2.
So Lindsay looks over here at the graph of F prime and says, hey, this point on F prime is at x equals 0 and -2. So -2 is the slope of F at that point. Somebody knew it? A couple. They need me to talk more about it. Please.
I don't get how you find that.
So I'm going to give you a series of pebbles here for you just to talk with me. We have the graph F. I don't really know what it looks like. Okay? But that means there's an F prime. Here's the graph of F prime. So right here on F prime, we have a point at -3, 1. So the -3 means if you came over here to the graph of F, and you went to point x equal -3, I don't know that y coordinate, but I would know that the slope right there is 1. Because the values of F prime tell me the slopes of F.
Oh, okay.
Did that answer your question?
Yeah.
2 pebbles. On the golden notes, front page towards the top, I have a reminder about that right here. F prime is the way we find the instantaneous rate of change of F, the slope of a line tangent to F, slope of F at a point. So that's what F prime is. Okay, back to the problem. So we now have everything. We just write down the answer. So y equals, the slope we found was -2, parenthesis, m subtract, not m, sorry, x1, so x subtract 0, plus the y coordinate, which is 3. And you can just stop right there. So 1 point for that. Questions? Cool. Keep moving. Number D. All kinds of extra notes here. Push those off for a minute. Do one thing at a time, don't do two. It says find f of -3. So I'm looking at f prime and they're asking me to find f. So Danica's chart reminds me that, let's see, if I know, I'm trying to find f, I have f prime. So I'm going this direction, which means I'm going to use the fundamental theorem of calculus. So on the golden notes, there's a reminder of that. Front page, on the right, halfway down, I need this equation right here. The integral of f prime is the change in f. So we need to use that. So, trying to find f of -3. Okay, do your best to wake up at this point. This idea is the most heavily tested idea on the entire test. The idea of using the fundamental theorem. So I know f, so I'm trying to find this, and I know this. So that means I want to integrate from 0 to -3. But I prefer not to integrate backwards, so I'm going to go -3 to 0. So take the integral from -3 to 0 of f prime. That has to equal f of 0 subtract f of negative 3. Trying to solve for f of negative 3. So pebbles for the whole room. I want to get this is what I'm solving for, so I'm going to move that over here. So when I put f of negative 3 on this side, just say it out loud. Will this f of negative 3 be positive or negative? A little weak. I'm going to take this, put it on that side of the equation. So will I write positive f of negative 3 or negative f of negative 3? Say it.
Positive.
Positive. Pebble for that. So I get f of negative 3. Now I need to move the integral to the other side. So I've already got f of 0. Is it going to be f of 0 plus or f of 0 minus? Say it.
Minus.
Minus, good. Pebble, sorry, thank you. Okay, question. Cool, keep going. We need to find that integral. Did this on a worksheet just a couple of days ago. So, a few days ago I should say. Negative 3 to 0. So I'm starting here, going to here. I'm integrating f prime. So I'm going to find two areas. The blue here, and I also need to find the red area here. Feels like kindergarten, lots of pressure. Questions? Okay, area above the axis counts as a positive, area below counts as a negative. This is 1 times 1, half of that's a half. This is 2 times 2, which would be 4. Half of that is 2. That area has to count as a negative. Do you need me to talk through that?
We can put negative 2.
It's kind of up to you. Some people, it bothers them if I put a negative 2 because they're like, area can't be negative. But as far as the integral is concerned, it must count as a negative value. So down here, I write f of negative 3 equals f of 0 is 3 minus parenthesis. The 1/2 counts as a positive. The other counts as a negative. And you can stop right there.
Can you explain this last equation?
So f of 0 is 3. I need to find the value of the integral. To find the value of the integral, I add up the area. Area above the axis counts as a positive. Area below counts as a negative. So I put a 1/2 plus negative 2. And you can stop there. Trouble for Preston. Question? Cool. The points on this one, oh, that's just the first part. That was f of negative 3. They gave 2 points. 1 point for finding the area of those triangles, 1 point for the correct answer using the fundamental theorems. Now I have to find f of 4. So let's see, get a new page so it's a little more space. So we're finding f of 4 now. So same thing, fundamental theorem. So I take, let's see, if I integrate from 0 to 4, f prime, that's going to equal f of 4 subtract f of 0. I do the rearranging, I find out that f of 4 is going to equal f of 0 plus this time. Question? Terribly exciting today, sorry about that. Let's see, I need to integrate from 0 to 4. So I start here, stop here. I'm integrating f prime.
Will we be finding the semicircle or the little trenches?
So you always find the area that is between the axis and the function that's being integrated. So we're finding this kind of funny little space here.
Huge.
That's a little big. So we're finding this area here. Cool. So what we really do, let's get some space here. That was a lot. Okay, f of 4 is equal to f of 0. F of 0 is 3. To find this integral, first of all, I'm integrating left to right, as usual. All of the area I'm finding is negative, is below the axis. So the entire integral must be counted as a negative. So I would put a negative right away. Like that. I'm going to find this area first. So raise your hand if you know the area that I'm now outlining. Just raise your hand. What's the area that I'm boxing? Show your hand. We got about half of you. Tough day, sorry about that. This is this blue area. So, Chase? E. Hands up if you agree with Chase. Pebble? So I take 8, and I need to subtract from 8 the area of the semicircle. My formula for area of a semicircle is pi over 8 diameter squared. So Pebble again, hands up, you can tell me the diameter of that semicircle. Diameter. So this is my formula. It's much better than the one you learned because it doesn't have all those halves in it. So pi over 8 diameter squared. So what's the diameter, Ellie?
4.
Raise your hand if you agree with Ellie. Put a squared on it. Close off the parenthesis, stop working.
Coolio.
Just make sure you have the negatives in all the right places. The area is below the axis, so that must be negative. We took the rectangular area, subtract the semicircular area, so that had to be a minus there. Questions? Awesome. Okay, part 5. Okay, part 5. A coffee pot has the shape of a cylinder with radius 5 inches. I can certainly box that. We've done this before. It's important to know when you have something that's changing or when something is constant. So say it out loud, please. Is the radius always 5, or is the radius, that's a bad way to ask a choral answer, sorry. Is the radius changing or constant?
Constant.
Constant. Pebble, you said constant. Preston is your greatest Pebble advocate. Constantly whispering in my ear.
I need to get your credit.
Okay, coffee pot is the shape of a cylinder with radius 5 inches as shown above. Good. H is the depth of the coffee in the pot, measured in inches. I want to take note of units. Where H is a function of time measured in seconds. Is the value of H, sorry, changing or constant?
What?
Try again.
Ask the question.
Is the value of H changing or constant?
They just took this to the wrong classroom, the wrong spot.
Oh, no. Thank you.
Well, how hard is that? Like 20.
Okay. The volume of the pot is changing at this rate. Raise your hand, please. When I read that, I'm going to write something down. The volume of the coffee in the pot is changing at this rate. Hands up if you know what I will write. Come on. When I read that, I'm going to write something down. Raise your hand if you know what I will write. The volume of the volume V of the coffee in the pot is changing at this rate. I'm going to write something down. What will I write? Just read the words. The volume V is changing at this rate. If you write V, you're talking about volume. I'm not talking about volume. What is it, Zach?
V prime.
V prime would be perfect. Related rate problem, I tend to use dV/dt, but same thing. So I'm going to write dV/dt is equal to negative 5 pi root h. It's not the volume that's 5 pi root h. It's the rate at which the volume changes. How many had their hand raised and knew it? Couple. Okay. Cubic inches per second. Then they give us a formula for volume. Okay. It says show. Okay, everybody, look over this way, please. When they say show, you think find, always. So don't think show, think find. And you can't use this. Like we need to find dH/dt. So this is a related rate problem. We did this in homework recently. So let's see, we have amount. Oh, wait a minute. This is the kind of problem that everybody dreads. So we use the word. D stands for Danica's chart. So it's amount and rate. They discussed two rates, dV/dt and dH/dt. Therefore, the corresponding amounts would be volume and height. Questions? Cool. So I've got the Danica's chart part done. R stands for rates. I have the rates listed. EA stands for find an equation that involves the amounts. There it is.
Wait,
Go ahead.
can you explain that last little part? The equation.
So the EA in dread reminds me that I'm supposed to find an equation that has the amounts in the equation. So there's my equation with the amounts in it. But because R, you told me R is never changing, I don't want to mess with R anymore. Just plug in the value that R will always have. Question? Cool. The last D stands for take the derivative of this equation. So now we take the derivative of both sides. We get dv dt is equal to 25 pi dh dt. I'm supposed to be finding dh dt. So divide. So I get dv dt divided by 25 pi is dh dt. They told me dv dt, so I write that down, negative 5 pi root h divided by 25 pi I divide factors, I get what they asked me to find. Negative root h divided by 5 is indeed dh dt. Question, please.
So this one already give you the answer, which I'll show that you know the word.
Yeah, so really, every time you see the word show, your brain should translate that into, I need to find what they're giving me. Boston Pebble for it. Why'd you-
You did dh over dh.
Somebody saw the error? I'll pay for that. Pebble, nicely done. You're very kind. Other question? Please.
So with these like free response or like whatever, like the written portion, do these like circle and square things, like should we, or should we like just like be clear kind of without writing and leave it to them to find it?
Oh, you don't have to actually box it.
You don't.
I mean, I would do this for sure. Otherwise, I want to make sure the grader knows I'm going like that. But if you stop here, it's fine. You don't have to box it. Pebble for that. Is that what you meant, Brendan?
Yeah.
Okay, next thing. This one was worth 3 points for that. Very nice.
Oh, question. So on the test, so on how you give it to us, A, B, C, will it give us A space, B space, D space?
Good question. Pebble for Preston. So let's just like this.
Just because, like,
Yeah, this is how the booklet that they give you looks. Is that what you meant?
yeah, I have space where I'm going to. Okay, cool.
No, good question. Questions? Cool. So, part B. Part B says, given that h is equal to 17 at time equals 0, solve the differential equation. Or h is a function of t. So pebbles to the whole room. Yeah, I can't think of a way to ask as a question. We need to do this. Sassy. Sassy method. So I had one class that they said I should sign up all my YouTube videos as stay sassy. I'm not sure I can say that. It's not really my personality, but you know.
That's why it's funny.
Sure, it's even funnier when you're right. Yeah. So anyway, stay sassy, cool. So let's see. I'm trying to solve the differential equation. So I start out with dh dt equals negative root h over 5. Oops, negative root h. Separate the variables, so multiply the dt across. I don't like dividing, so I would prefer to multiply. Move the root h over to this side. Questions? That's worth 1 point if you do that. So now we'll change color. We anti-differentiate both sides. This is h to the negative 1/2 dh. The antiderivative of negative 1/5 will just be negative 1/5 t. Questions? Please.
How do you know to do the sassy thing? Like, what's the key words that?
2 pebbles for this question. The black cloaked beings.
What?
Have I not talked about the black cloaked?
Yeah.
Just making sure. Right?
Yes.
The people who write the test.
Oh,
That
yeah.
live in the cave.
I thought you said beans.
Oh. In Maya's head, she's got this image of like this
Beans and
black pinto bean with a hood. Sitting at a table with 12 other beans. That was good because we're all getting a little sleepy. So this is not yeah, the black cloaked creatures. Okay, no, your question is spot on. Look at me. Come on, look at me. Okay, they have come up with, it seems like every year, a different way to phrase that you're supposed to use the sassy method. So I can't give you one phrase that means, oh, I'm supposed to use the sassy method, okay? But the keywords to look for are, if they give you a differential equation, okay? Now, just because they give you a differential equation doesn't mean sassy method. But it's possible. They give you a differential equation. So look here close. Come on. This equation has h and t, right? If they say solve the differential equation or find the solution to the differential equation or something like that, so you can find h of t. So it's whenever you're going from this to h of t, that's when you use the sassy method. Whenever you're starting with the differential equation, you're trying to find h of t.
Can you explain what we're really kind of doing here?
So this is a derivative, right?
Yes.
Pebbles for the whole room. In every problem you encounter in calculus, what is the purpose of the derivative? Hands up, come on. We're going to use it over and over again. If you're having a hard time remembering, look at your golden notes, go to the front page, top, and read this box. dy dx. So what's the purpose of a derivative? Hands up, come on. What's the purpose of a derivative in any calculus problem? Avery? Finds the instantaneous rate of change, means finds the tangent slope. How many knew it? Pebble. So this is the formula for finding the slope of some curve, right? I don't know what the curve looks like. But this curve is h of t. That's the derivative of h. Okay? You use the sassy method when they give you the differential equation, or the derivative, and you want to find the original equation. That's what this is for.
Because you're going from.
You're good. You're basically going from derivative backwards. That's why we're anti-differentiating.
Yeah, that's what the A comes in.
Yeah, the problem only becomes a bit more difficult because you've got the output variable h, and you've got to find the constant and that sort of thing. So there's a few more steps, but essentially it's anti-derivative. Does that help? Help.
How did you get from integral negative 150 of t? Like, where does the d go?
So I'll help you. You'll get it in a second. So this literally means you started with something, right? The variable here is t. And when you took the derivative, you got negative 1/5. What did you start with?
T. Okay.
negative 150. Like the derivative of negative 150 is just negative 1/5. So this is antiderivative, so we're just going the other way.
Okay.
So we found the antiderivative, so this symbol disappears and this symbol disappears.
Okay.
Does that answer your question?
Yep.
Double. Everybody good to hear? So now I need this antiderivative. So that's going to be h to the negative 1/2 plus 1 divided by negative 1/2 plus 1, negative 1/5t. Questions? Cool. So let's get rid of this. We can get rid of this. Did I answer your question, Maya? Okay. So let's see. Keep going here on the antiderivative stuff. Dividing by 1/2, same as multiplying by. What's negative 1/2 plus 1? Louder?
1/2.
Dividing by 1/2, same as multiplying by 2. There we go. So this is 2 square root of h equals negative 1/5 t, and we do have to have a constant. That gives you a second point. Now we're going to constantate. So,
150.
oh, how many saw the error? Double. So back up here. Plug in the values. So we've got 2. The value of h that they gave us is 17 when time is 0. Questions? Herb? So that means c is equal to 2 root 17. That gives me 2 more points. Constantating is the most valuable part of the process. It's the easiest and the quickest to get points.
When do you quit from there? Because I don't like the 6 step.
The isolation is not bad. Sometimes, but not always. You shouldn't quit. You should just try it.
Okay, 5 out of 6.
So we go, let's see, 2 root h is equal to negative 1/5 t plus 2 root 17. Got to get the h alone. This one's easy. So we multiply both sides by 1/2. Square both sides, we're done. That was definitely worth trying. All squared. Question? Cool, keep going. Part C. No breaks. Part C says, at what time is the coffee pot empty? Well, this is an unusual case. The answer to B is required to do C. So if you didn't find this, you can't do C. So you just lose those points as well, which is, this is how it goes, but that doesn't happen very often, so I don't stress about it.
I would be screwed.
But anyway, in part, sorry, my knee is suddenly not working properly. So my equation for h is how I find the height at any time. I want to know when, at what time is the height 0. So I put in 0 for h, and I need to solve for t. It's not hard, just unscramble it. First thing, take the square root of both sides. So that will get rid of the squared. What's the square root of 0? That's easy, 0. Now I need to get rid of the 1/2, so I multiply both sides by 2. Same thing. Move the negative, move the 2 root 17 over. Multiply both sides by -5, you're done. Good answer. That one is worth, let's see. You're good. Only 1 point for that, so even if you couldn't do the other parts, you didn't really lose out very much. So. Cool. Last one. 6. Okay. You give us a function, nothing else given. That's my favorite kind of NP problem. I hate waiting through all the words. This is my preference. Is f continuous at x equal 3? Explain why or why not. Okay, on your golden notes, you have the answer to what we need to do. Front page, towards the bottom, says right here. The function is continuous if there are no removable discontinuities, jumps, or vertical asymptotes. That's what I look for if it's a graphical problem. This one's not graphical, so I look at the second part here, the definition of continuity. To show that the function is continuous, I must show this. Okay? So I'm going to go to work. I find the limit. You have to write it all down because it said, explain my answer. So I say the limit as x approaches 3 from the left of f of x. You must have good notation or they won't give you the points. Please raise your hand if you know what number gets written here and how you find it. So hands up. Come on, think with me. What number do I write here? Because again, memorizing without understanding is hard. So what number gets written here and how do I find it? What about half of you? Let's go, Maddie.
Plug it into the first equation, the square root of x plus 1.
Good. So I say close to 3. Stay with me, Maddie. Close to 3 plus 1 would be?
4.
Close to 4. And then square root of close to 4 would be?
Close to 2.
Close to 2. So this limiting value is definitely 2. How many knew it? Couple. 2 for Maddie. Then I go here and find the limit as x approaches 3 from the right of f. Same kind of reasoning. Let's see, 5 minus close to 3 is definitely going to be close to 2. Now I need to find f of 3. Just say it out loud, please. Do I use top or bottom equation? Top or bottom? So it's equal to 3, so I use the top. So plugging in exactly 3, I get exactly 2. Therefore, f of x is continuous at x equal 3. And that gets you 2 points. Double check how they did it, just make sure I'm not forgetting something. Yeah, they just find the limits and the value of the function, so we're good. Question? Please, Mike.
So you don't have to explain it in words if your work is there to back it up? Is that
Correct.
And that's always?
That is always the case.
Correct? Unless it...
Usually, well, so that I've tried to create on the golden notes the answer to your question by, I know for certain if they say prove that it's, the function is continuous, that you can simply use this definition without a whole lot of words. Like I had the little therefore, but that's all you really need. A lot of the other questions that are like why or why not, that sort of thing, the backside has appropriate phrasing. The way I came up with the backside of the card is I went through years and years and years of AP questions, and I kept looking for the most concise way they had specified that you could answer all these different kinds of why or why not questions, and I just wrote them on the card. So these are straight off old AP tests, so that you can be comfortable that if you use this wording, you'll be just fine.
Okay.
Does that kind of help? Okay. So there are all of these types of cases where you do have to use words, help them out there, good. Just make sure the button pops out. People always lock it. You good? Okay. Anybody else here? Part B. Find the average value of f on the closed interval. To find the average of f, I integrate f. So I need to find the integral of f from 0 to 5. And I must multiply by 1 over the width. So I have to have a 1/5. So that's how I'm going to find the average. Question? Okay, in this case, f has two different formulas. So I have to now split the average into two different integrals. You can't do it the other way around. You can't take two different averages. Okay, that's not what we're doing. We're averaging f from here to here. So this integral can now be broken into its two parts. So this equals 1/5, big parenthesis, the integral from 0 to 3 of that part of f plus the integral from 3 to 5 of the other part of f. And then close big parenthesis. Question? So we're finding the average of f, which means we have to integrate f and multiply by 1 over the width of our integral. Since f has two pieces, we have to break the integral into two parts. So, doing that much would get you the first point. I don't know what this k equals 0 thing is. Skip that. But that's 1 point. So, this is really just x plus 1 to the 1/2. So I can use my extended power rule. So that's going to be big 1/5. So I'll have, let's see, 1 over a, ax plus b, to the 1/2 plus 1, divided by 1/2 plus 1. And that has to be barred from 0 to 3, plus the antiderivative of 5 is just 5x. And it'd have x squared over 2. Add 2. Barred from 3 to 5. If I get that far, I get 2 more points. Okay, questions? Cool. The good news now is you really don't have to do simplification. Just plug stuff in and it's good enough. This kind of bugs me to have 3/2 on the bottom, so I'll rewrite it as 2/3. But you don't have to. So leave the 1/5 out here all by itself. Big parenthesis. See, we're going to have 2/3 multiplied by, plug in the 3, so that'd be 3 plus 1 to the 3/2 power. Subtract, we have 2/3 multiplied by 0 plus 1 to the 3/2 power. That took care of all of that. Plus, plug in the 5, so I'd have, let's see, 5 times 5 minus 5 squared divided by 2 minus, now there's going to be 2 terms here, so I have to have another parenthesis. 5 times 3 minus 3 squared all over 2. Close and then close again to get the point. And I'm done.
Why do you need 1/5?
So the 1/5, remember, was all of it.
Yeah.
So this parenthesis matches this one. These two are for the subtraction.
Okay.
Double for Maya.
So I don't need to find 4/5.
You don't have to do anything else. Like right here's where you're looking.
No, I'm talking about the answer that it says.
Oh, because they worked it all out. Yeah, they're overachievers. Question? Cool. Part C. That was not a good comment, but ignore that. Okay, it says suppose the function g is defined by this mass. We'll avoid cheating here for a minute and put those off to the side.
But cheating is so satisfying. Just kidding. Joke. Oh.
The jury will disregard that comment.
We all know I'm not cheating. I'm a D-, guys.
The evidence will speak for itself. Okay. So it says they give us this function g. It says g is differentiable at x equal 3. What are the values of k and m? Okay, eyes on me. Look up. I'm pretty sure that as I work through this problem, and I'm going to run out of time, I get to the point where I start to spin my wheels. Like I start going, I'm starting to feel frustrated. So you know what you're supposed to do, right?
Skip.
Skip, yeah.
Yeah. Hallelujah.
Everybody's like a big fan of skipping. Skip, please. You're going to be taking the test in the gym and I'll say like, skip!
Can we get in trouble for like talking every day?
Yeah, I think so. Okay, but I can't get started here, so watch. So this is memorized. Like you can memorize this. They say G is differentiable. We're supposed to find constants, right? I've taught you. I gave you a flashcard. When they ask you to find constants, don't go looking for the constants. Do other things, and hopefully you'll find them. So if G is differentiable, that means G must first be continuous. So I just start doing my little continuous thing. So I say the limit. Okay, the bell's going to ring in about 90 seconds. I'm going to keep talking, so if you need to leave, just leave quietly, because I want the video to keep playing if you want to see the end. But it's like, no, quit, skip. Okay, so look, we take the limit, don't talk please, as x approaches 3 from the left of g. That's not too bad because look, plug in close to 3, plus 1's close to 4, square root of that's close to 2, so this is going to be, the limit's value is 2k. The value of working until it gets hard is you get a lot of points for making progress. So don't skip too soon, okay? Like I'm not feeling lost yet. So now I do the limit as x approaches 3 from the right of g. So let's see, that's going to be, thanks for coming, stay sassy. Okay. Look, close to 3 here would be like m times, so it'd be like 3m, the Post-it note company. The bells are wacky. New intercom system. Okay? Now I need to find f of 3. That's going to be exactly 2k.
Would you have to find G of 3?
Oh, gee, thank you. I just got distracted by the bells. So g of 3 is going to equal 2k again. And to be continuous, since g is continuous, I don't really have to write that. They just want me to find the value, so I don't have to have justification. So I know that 2k must equal 3m plus 2. That's not my answer, but that's going to be helpful. Question? You okay with that? Just checking the scoring. My goal is to get a good score on the test. That was worth doing. I got a point for getting that far. Keep going. I don't feel stuck yet. Differentiable. To prove that, I have to take the derivative of this formula. So G prime, this should feel kind of familiar. There was some
Yeah.
recent problems, we've done problems like this. So G prime is going to equal, the k is a constant, the derivative of square root, so k is going to be 1 all over 2 times the square root of x plus 1 multiplied by the derivative of x plus 1, which is just 1. So that's G prime for x between 0 and 3. Although it may not include 3. So I don't include that yet. This derivative is just m. So that'll be for 3 all the way to 5. Questions there? Please,
How do we
Mary.
know that it is equal to 0? Like, grid, and also like, oh, never mind, actually.
You're doing
this is
great.
the we know that's like the limit to everything, so it's just a question if it's on differential or so never mind, that makes sense, because those are just like the.
Let me explain a little bit.
Okay.
I know it starts at 0 including, that's fine.
Yeah.
The reason I don't put the equal on 3 is because a piecewise function could have a corner.
Yeah.
And I've got it.
Because it's the
Well, it did say, it says if G is differentiable, so they're declaring it's going
Yeah.
to be, so it's okay to put it.
Fine.
It's just if you're not sure, don't put
Okay, no,
the
that makes
equal
sense.
there. I don't put the equal here because that wasn't
No,
part
of
of the
course, yeah.
definition. Pretty good? Cool. So to prove differentiability, you got to do this again with G prime. So you're very patient. So I find the limit as x approaches 3 of G prime. So that's this one. So let's see, that's 3 plus 1. So that's 1/4 k roughly. That would be the limiting. The computer stopped working. Good there. To the other limit, that's 3 minus, sorry. So then the limit, wow, as x approaches 3 from the right of G prime, that's just m. G prime of 3 has to equal this again, so that would be 1/4 k. So now these two equations have to equal each other. So 1/4 k must equal m. Questions to that point?
Oh,
You okay?
yeah, that just clicks.
Good. So then, let's check our points again, just to, that gave us the second point. So now if I'm trying to solve for k and m, I need to substitute, right?
Yeah.
So it didn't turn out to be as bad as I thought. I was remembering perhaps a worse problem. It's not that bad, just keep working. So I say, let's see, 2k,
Oh, really?
new colors. So 2k is equal to 3 times 1/4 k plus 2. So 2k is equal to 3/4 k plus 2. So that means 2k is the same thing as 8/4 k minus 3/4 k is equal to 2. So 5/4 k is 2. So 5k is equal to 8. So k is equal to 8/5.
And then you just put that in for that.
And then you plug that in.
You get
for m.
8/4 by dividing.
So I multiply the 4 across
So from the second bit to the third bit.
from here to here.
Yes.
So I move this to the other side,
You minus.
minus it to the other side. 2k is the same thing as 8/4k.
Oh, that's the same thing.
So I could have the same denominator.
4k minus 3/4 k. Okay, that equals 2. Okay.
So then,
What's K?
m is equal to 1/4 times k, so that'd be 1/4 times 8/5, and I don't have to do anything on that, I can just stop.
So K equals 8/5 is your answer, and then for M equals, how do you get M?
You plug in. Oh, okay. You plug in the K.
Right, because it said that 1/4 k was m, so good work, you guys.
Which
And then you
equals-
just simplify.
Yeah, you can just stop there, you don't have to do
Okay.
anything.
Oh, but it is 8/20.
So I had my extra credit done yesterday. I sent it out on a piece of paper. That's totally fine if it's too late. Okay. I might as well ask.
No, you're good.
Where should I put it?
I only chair is good, Dylan.
Okay. Thank you very much.
Good job, you guys, well done.